morning, good afternoon, wherever you are. Welcome to NBP Hotseat. Today we'll have a great interview with Mr. Simon Irish, who is the CEO of Terrestrial Energy. Simon will be sharing with us some developments of Terrestrial Energy, their current status, and also a future prospect. Let me welcome Mr. Simon Irish. Simon, welcome to NBP Hotseat. How are you doing, sir?
Very good, Zaf, and thank you for having me. Good to see you today.
Wonderful. So, Simon, let's start off first by having you share with us the background and history of terrestrial energy.
Well, thank you, Zaf. Well, Terrestrial Energy was formed probably about maybe 8-9 years ago, and it's formed by a group of people who recognized that the nuclear industry was struggling. It was continuing to struggle, and that struggle was a commercial one. Conventional reactor technologies and power plants that use them were becoming uncommercial. Namely, they were becoming unaffordable to build. And once you built them, they generated power which is uncost competitive against alternatives. The energy market globally is competitive, and many industries have committed to innovation over the last 20 years, and a significant number of sectors have seen a great deal of success. Obviously, natural gas in North America with fracking, that was a transformative way of extracting natural gas from shales. And the wind and solar community have compared to where they were 15 years ago, have moved their business and their market share along in a extremely impressive way. For nuclear to do the same and to respond to the competitive demands in energy markets, it too must embrace innovation, and if it doesn't, it'll see its market share shrink, and that's exactly what we've been seeing over the last 10 years. So the group that formed Terrestrial Energy recognized there was a very, very clear link between technology and technology choices and the economic profile of a nuclear power plant. We recognized that those linkages were associated with the use of light water reactor technology. If I can sort of continue this thought,
Yep,
light water reactor technology, and a nuclear power plant built with light water reactor technology is fundamentally, at a basic level, a very inefficient machine for generating nuclear power. And a machine is a machine that converts thermal energy into mechanical energy. That is what a machine is, whether it's a moped engine or a nuclear power plant. That's what it does. And a conventional nuclear power plant, particularly one that is small, that conversion rate is no more than 30%. For a coal plant, that conversion rate is in the high 40s, and a combined cycle natural gas, you're talking very high 40s, low 50s. So a nuclear power plant that is stuck in a box with a number 30 on is an inefficient machine in creating power. And being inefficient, it'll be capital inefficient, and the cost of the power it generates will reflect that inefficiency. Now, you can change that equation dramatically by looking at generation 4 technologies, because although they are very, very different technologies, they generally share one thing in common, and that is they operate hot. They generate much higher quality heat, and their thermal efficiency by direct extension is superior than the thermal efficiency of a generation 3 system. So in our case, choosing a generation 4 technology, and specifically a molten salt, we have a much more efficient machine when it comes to creating electric power. In our case, our machine operates at 44% thermal efficiency. So that's compared to 30%. So going from 30% to 44%, you are definitely on a very exciting path to a power plant that has a transformative commercial position in competitive energy markets. So the company was founded, and its purpose is to bring one of those power plants to commercial markets, and do so in a time frame which is relevant for private capital and relevant for our industrial partners and the utility sector and governments as well. So that is the company's purpose, and it was founded, as I said, maybe 8-9 years ago to bring our design, the Integral Molten Salt Reactor, a generation 4 nuclear power plant, bring that to commercial markets by the end of this decade.
Wonderful, wonderful, and it's a great that you mentioned the integral molten salt reactor technology. I believe it's a unique technology. It's pretty fascinating. Are there special features, or could you provide some maybe brief insights into this technology without being too technical, of course?
Well, in terms of being unique, there are many aspects of our power plant that are not unique, and that's to some extent why it's commercially viable in the time frame I've mentioned. I
Yep.
mean, this is in many respects a classic molten salt reactor. It stays as close as we possibly can to the molten salt reactors that have been demonstrated previously, principally the one at Oak Ridge National Lab.
Yep.
It's a fluoride chemistry system. It's graphite moderator, so thermal spectrum, once through fuel cycle. And in terms of not being unique, we don't want to use a unique fuel. We use standard assay, low enriched uranium, which is vitally important if you're meant to, if you're to be successful with your operability case to your utility customer. Our nuclear fuel, standard assay, low enriched uranium, that is the level of enrichment which is commonly available in nuclear supply chains today. So you don't want to be unique with respect to your fuel, you want to be standard. If there is a unique design feature of our integral molten salt reactor, it's probably the integral architecture of the core to ensure that the lab reactor that is our prototype that was demonstrated previously, to ensure that that becomes the industrial reactor, one that's capable of having an uptime of 90 to 95%. We have a replaceable core unit, an integral molten salt reactor, where all the primary components of the reactor core, the pumps, the moderator, the heat exchangers, are placed into a sealed unit, a replaceable unit called the IMSR core unit. And it's that unit that's replaced every 7 years. So that is what is unique about our system. But many the other aspects about our power plant are not unique. And that's also the exciting thing.
Wonderful, 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 Simon. So I guess, on everyone's mind when it comes to SMR, and according to the IEA, there's around 60 plus unique designs, quite a lot. I guess in the case of terrestrial energy, I mean, when will your technology be up and running? Or can you outline some of the timeline that you're working with moving forward, Simon?
Yes, well, since we formed the company, we set our objectives on having a first plant operating, a first commercial plant operating by the end of the decade. Now, for that project to be realized, you also need a critical business partner. You need a utility that is willing to partner with you as the owner operator of that plant and in the same time frame. Now, from our perspective, we have a utility in Canada that has a ambitious project and a committed project to commission a small modular reactor by 28, first one by 2028, 2029, at its site, Darlington site in southern Ontario, Canada. Now, that project that is being run by Ontario Power Generation is probably, I would say, it's certainly North America, one of the most advanced SMR deployment projects for a commercial plant in North America. So that is the other side of this equation. Obviously, we are the technology developer. We believe that we can develop our technology for deployment in a 2028-29 timeframe, but you obviously require for this equation to balance, for this project to be viable, you require utility that shares that aspiration. And OPG absolutely shares the aspiration of deploying a small modular reactor in that time frame. And it is what is interesting is the level to which it is now supported by the Canadian government and the Canadian provincial government as well.
Wonderful, wonderful. So I guess Canada is most likely going to be the first home of terrestrial's IMSR technology. And moving outside of Canada, if I could ask Simon, is there a specific profile of a country which could benefit tremendously from your technology, Simon?
Well, I see two general country profiles. The first one is the classic profile that exists today, a Western economy or an advanced industrial economy that's had nuclear for many decades. Now, the problem about that economy is that the age profile of the generating fleet, the nuclear power plants in those economies, is long. Namely, if you roll the clock forward 1 decade, 2 decades, many of those plants will be approaching end of operating life. There's some uncertainty to which that operating life can be extended. Excuse me, sorry. Can be extended. There's some uncertainty regarding the extent to which that operating life can be extended. In the United States, for instance, we're seeing a plant that was originally designed for 40 years having a license extension to 6. And I think one has been successful with extending it to 80 years. But by and large, that fleet is aging, and it's aging quickly. The UK will have lost virtually all of its nuclear power, its existing nuclear facilities by the end of this decade, by the end of the 2020s. And what's interesting there is it was the UK that turned on the very first civilian power plant in 1956. So perhaps not that surprising that this retirement wave is most critical today in the United Kingdom, but that retirement wave is coming to many of the traditional nuclear power markets. So that's one country profile, and they're going to have replacement for nuclear capacity. They recognize how critically important nuclear is in the energy mix, and how so much more challenging the clean energy policy goals become if you're trying to not only replace fossil fuels but also replace nuclear as well. I don't think anyone has demonstrated they're being able to do that successfully. So nuclear must stay part of the power mix. And the question is what technology is going to allow it to do that, and that's where Generation 4 technologies come in. So that's one country profile. The other country profile are the fast-growing economies in many other parts of the world, fast-growing from an economic perspective and also a population perspective as well. And those economies have rapidly growing primary energy needs, and with electrification, rapidly growing grid needs as well. So the question is, what is going to supply that additional large electrical demand over the coming decades? Those nations recognize that it probably cannot be coal. Western nations may have done that 100 years ago, or even as recent as 50 years, but they can't do that because of a global commitment to reducing greenhouse gases. So that's where nuclear, next generation nuclear, SMRs, Generation 4 nuclear, those technologies become potentially very, very valuable to drive that economic growth in amongst those many countries.
Wonderful, wonderful. So, Simon, you mentioned earlier with regards to one of the key success factor, potential success factor is having a good potential partners, right? And you found one in this Canadian utility. I guess moving forward, is Terrestrial also looking at partnerships opportunities with other kinds of verticals or firms? And if yes, or what kind of partnerships are you looking for?
Well, I think it's clear that if you are to successfully commission and operate a nuclear power plant, you need to bring together many parties, to make that project a successful one. It's not just the utility; it's also many companies in the supply chain, the nuclear supply chain, that today have considerable expertise in specific areas. So, with respect to deploying our system, we're looking broadly for relationships both on the supply chain side and also potentially also on the utility side as well. And those relationships naturally work with respect to geographies. There's some parts of the world that we would feel would be much better off by partnering with an industrial that has a existing and very sophisticated presence in that geography, and that's probably true at an industrial level as well. Generation 4 systems are not just deployable and to serve power needs, grid power needs. They can also be deployed to supply thermal energy for many industrial activities, particularly in the petrochemical and chemical sector as well. So in our case, there may be a good sense in us partnering with a chemical or petrochemical company to successfully deploy our technology in new industrial markets.
Wonderful, wonderful. So Simon, recently Terrestrial has been in the news, and for good news, positive developments, that's been happening in the past couple of weeks, couple of 1 or 2 months. Perhaps you could want to share. I'll let you share some of the interesting developments. From what I'm aware, the news ranges from receiving funding from the Canadian government to your partnership with a simulation company. Perhaps you want to shed some light on some of these interesting developments.
Well, certainly the last 3-4 months has been a very interesting time, and at a general market level, you've seen from in North America, the Canadian and the US government are getting ever more committed to supporting the deployment and development and deployment of small modular reactors. In the United States, the Advanced Reactor Demonstration Program was announced. In Canada, we received $20 million from the Canadian government's flagship Strategic Innovation Fund. And also in Canada, the industry is expecting the release of the SMR Action Plan, which is the next iteration of the roadmap, which was published, I believe, about 18 months ago. So there's a lot happening on the policy file, which is very, very relevant for our project and what we're doing. So in that context, we are pleased with the progress we've been making. We've had a couple of procurement announcements as well, one of which was L3Harris. We're not designing a reactor per se, we're designing a power plant, a nuclear power plant. A important element of that program is going to be the development of a simulator which simulates the operation of the entire power plant. We announced recently a relationship with L3Harris. L3Harris has got recognized global expertise in this area, so natural for us to be partnering with L3Harris to develop that simulator. With respect to our relationships with the Canadian government, we're a nuclear company. Relationship with government, an appropriate and supportive relationship with government, is critically important to your business. So we're very pleased to announce, in conjunction with the federal government, as I mentioned a few moments ago, 20 million Canadian dollars from Strategic Innovation Fund. And that happened almost concurrently with OPG's announcement that it was proceeding with a group of 3 SMR technology companies. Following an extensive period of due diligence, they looked at many SMRs. They've agreed to move forward with 3, one of which is our Integral Molten Salt Reactor, as they move into the next stage of their program to potentially deploy a small modular reactor at their Darlington site in southern Ontario. So yes, it's been a very busy time for us over the last, in a very good way actually, a very busy time for us over the last 3 to 4 months.
Fantastic. It's always good to be busy. It gets worrying when you're not busy and you don't see emails coming in or calls being made. So fantastic. We're delighted at the progress that Terrestrial is making. So I guess, Simon, rounding off, what are your thoughts on the prospects of the adoption of SMR technology globally, not just for Terrestrial, but your genuine insights on SMRs and its future prospects?
Well, I think what I see today, which is deeply, deeply healthy, is the depth and breadth of innovation in the nuclear industry. There are many companies pursuing different technologies, different designs, of different ideas about how a market need can be met. And all of that is extremely healthy. From that process, clearly not everyone's going to be right, but from that process, there will be companies and technologies that emerge that are transformatively better and deliver so much more value to those that want to use these technologies for profitable, commercial activities, one of which is power generation. So I see the process underway today as a process that will deliver the successful technologies. Obviously, we believe that we have a deep focus, laser focus on the market problem and the market need. We know exactly what our purpose is, and we are using a set of technology and design choices to ensure that our power plant is indeed competitive in global energy markets. But the process underway at the moment, I think, if you roll the clock forward 10, 20 years, we have a healthy innovation cycle at this point in time, and I'm sure it will deliver technologies that are going to be globally successful.
Wonderful, wonderful. Simon, thank you so much for spending the time to share with us your company's vision and current developments. We wish you all the best, and hopefully, we'll have a chance to speak again in the near future when you can share with us the successful deployment of your technology. Thank you very much, Simon. Have a nice day.
Pleasure to join you today. Thank you, Zach. Thank you.
Wonderful.